This is part 18 of Entity Framework tutorial. In this video, we'll discuss implementing table per hierarchy inheritance in the Entity Framework with database first approach. We'll be using this employees table in this demo. Now this table is used to store both permanent and contract employee details. Now if we take permanent employee, it's usual for permanent employees to have annual salary. Hourly pay and hours worked are not relevant to permanent employee. If you take contract employee, they usually have hourly pay and hours worked, but annual salary is not relevant for them. However, these columns ID, first name, last name and gender are common for both the employees. Now, when we use ADO.NET Entity Framework and generate an entity based on this table, by default it's going to generate one entity, as you can see here. Let's look at that in action. Now I have already created the employees table. Here is the SQL script that can do it. I'll have the script available on my blog in case you need it. Now let's flip to Visual Studio. Here I have an empty ASP.NET Web Application project. To this project, let's add a new item, and we want to add ADO.NET Entity Data Model, and let's call this Employee Model. We want to generate the model from the database, and let's save the connection string as employee DB context. So this is going to connect to the database and retrieve all the tables, views and stored procedures. So let's select the employees table and click finish. So this should generate the employee entity based on that employees table, and if you notice, by default we get one entity. Now let's say in our organization we have two types of employees, permanent employee and contract employees. Now what we want is, instead of this one entity, we want to have three entities, because from an application perspective, when we are working with permanent employees, we want to create an instance of permanent employee class. Similarly, when we are working with contract employees, we want to create an instance of contract employee class. Okay, so for that purpose we want to divide this one entity, this one employee entity, into three entities, as you can see here. So the employee entity, that's going to be the base abstract class. So we want this employee class to be an abstract class, because our organization has just two types of employees, permanent employee or contract employee. Okay, we don't have any other type of employees. Now this base class here is going to contain the properties that are common for both the employees, ID, first name, last name, gender. So they're going to be present in this employee class, and this employee class is going to be an abstract class, because we don't want developers to be inadvertently creating instances of this base abstract base class. That's why let's make it an abstract class. And then we make contract employee class, which is going to derive from that employee class, and this class should have only the properties relevant to contract employee, in this case hourly pay and hours worked. All the other properties it's going to inherit from the base class. Similarly, we need another entity here, permanent employee, and this is going to have properties relevant to permanent employee, in this case only annual salary. All the other common properties are going to be inherited from the base class. So let's see how to achieve this hierarchy. Now, in spite of having an inheritance hierarchy here, we still want this data to be stored in the same table. So that's what table per hierarchy inheritance is all about. In TPH inheritance, that is table per hierarchy inheritance, one database table is used to store data for all the entity types in the entire inheritance hierarchy. Okay, so let's look at this in action. So let's flip to Visual Studio. So we need two more entities. So the first step is obviously to add an entity, and let's call this permanent employee. Okay, now for this entity, the base type is going to be employee, which is this entity. Now look at this, as soon as I have selected that base type, all the other options are disabled here, because by default it's going to get the ID, which is the key from the employee entity, and similarly all the other properties which are present in the base class are going to be automatically derived by this permanent employee. So let's click OK. So there we have the permanent employee. Look at that, there is this arrow mark indicating that inheritance relationship, and look at this little arrow right here which is pointing towards employee. So basically this indicates that this is a derived type from this employee entity. Okay, and what are the properties that are specific to permanent employee? Annual salary. So let's cut that and paste it within permanent employee. And similarly, let's add another entity and let's call that contract employee. And again, for this, the base type is going to be employee. So let's click OK. So we have contract employee here. And again, contract employee, what are the properties specific to it? Hourly pay and hours worked. So select both of them, cut those properties, and then paste them within contract employee. Okay, so we have the employee base entity, and permanent employee and contract employee entities are deriving from that base entity. Now at this moment, if we try to validate the model, we will get some validation errors. Now look at this. Entity type contract employee is not mapped. Similarly, permanent employee is not mapped. All we have done so far is move the properties to the respective entities. But then, if you look at this employee entity, if we go to table mapping option, look at this. Employee is mapped to basically employees table. Okay, so employee entity is mapped to employees table. We have ID, first name, last name, gender, columns mapped to those respective properties, and similarly discriminator mapped to discriminator property. But annual salary, hourly pay, and hours worked, they are not present in this entity. That's why they are not mapped to the employees table from there. Now annual salary is present in permanent employee entity, so we need to map that property to a table column. So right click on the entity and select table mapping, and here we need to map permanent employee to the same table, which is employees. Now notice that annual salary is automatically mapped to annual salary property. Okay, and similarly we need to map the contract employee properties to the respective columns of the employee table. To do that, right click table mapping and select employees table, and notice that hourly pay and hours worked columns are mapped to the respective properties. Okay, now at this point, if we try to validate this model, look at that, we have an error which says employee, permanent employee, and contract employee are being mapped to the same row in table employees. Okay, so mapping conditions can be used to distinguish the rows that these types are mapped to. So now we are mapping all these three entities to the same employees table. Now we need to tell entity framework when an employee can become a contract employee, similarly when an employee can become a permanent employee. The first thing that we need to do here is we don't want end users to be creating, not end users, I mean the developers to be creating instances of this employee class accidentally. So we want to make this an abstract class, and to do that, let's go to the properties of that entity, and here we have this abstract property. Just turn that to true. So now this is an abstract class, so nobody will be able to create an instance of this class. This is just there to act as a base type for these two classes that we have here. Now we need to tell entity framework when an employee can become a permanent employee, and similarly when an employee can be contract employee. Now if you look at the data that we have here, let's actually look at that in slides. So if you look at, this is the column that determines whether if an employee is a permanent employee or contract employee. If the discriminator column says permanent employee, then he is a permanent employee. Otherwise he is a contract employee. Okay, so this is the column based on which we determine whether if an employee is a permanent employee or a contract employee, and that's what we need to tell the entity framework. And the way we do that is by conditional mapping. So we go to table mapping again. So this is permanent employee. So what we're going to do here is map this discriminator column. So when discriminator equals this text permanent employee, that's when an employee is a permanent employee. Okay, and similarly let's go to contract employee and then map the discriminator column. So when discriminator is equal to this text contract employee, then that employee is a contract employee. Okay, so we are using that discriminator column to determine whether if an employee is a permanent employee or a contract employee. At this point, if we validate the model, we are still going to get another error. That is basically because we are using this discriminator column in conditional binding in both of these entities, and we are also using it in the property mapping. Keep in mind, a column can be mapped only once. Since we are already using the discriminator column in conditional mapping, we cannot use it again in the property mapping in employee entity, so we need to delete that. So let's go ahead and delete it. Now let's validate this one, and look at that, validation completed. Okay, so now we have three entities, but still the data is stored in a single table. Now let us see how to actually query the data and display that in a web form. Now what we want to do is design a web form like this. We are going to have a radio button list with these three options: load all employees, load permanent, and contract employees. Now when we select load permanent employees, it should only load the permanent employees, and similarly when we select load contract employees, only contract, and if we select load all employees, it should be loading all the employees. Let's see how to achieve this. So first of all, let's go ahead and design the web form. So to this project, let's add a new item, and we want to add a web form. Let's quickly set the style attribute here, and let's set font family to area, and let's drag and drop a grid view control onto this web form. And then we also need a radio button list, so let's drag and drop the radio button list. And for this radio button list, we need those three options. So let's say here text is load or load permanent employees, and let's say value equals permanent. Okay, similarly we need to have list items for load all employees and load contract employees. To speed things up, I have already typed the required code, so let's copy and paste it within Visual Studio. So here I actually have load permanent employees, load contract employees. Let's actually change this to load all employees, and let's say the value is all. Okay, let's format this properly. Alright, and let's set the auto postback property to true for the radio button list, so that it will automatically post back when the selection changes. Let's auto format this and choose the colorful scheme. And when the selected index changed, what we need to do now, we have the employee DB context class, so let's go ahead and create an instance of that class equals new employee DB context, and then we are going to use switch statement here. So we are going to switch on the radio button list 1 selected value. So case, so when the selected value within the radio button list, if it is, for example, permanent, then what we want to do, we want to load only permanent employees. So I'm going to use employee DB context here, and then it has got employees properties, which is going to return all the employees, but we don't want all the employees, we want only the permanent employees. So here we can use this of type. Okay, and then what type of employees we want only permanent employees, and then let's convert that to list. So that is going to be the data source for the grid view control. So grid view 1 dot data source equals that, and then invoke data bind method, and a break. Similarly, we need to have case statements for contract and to load all employees. And again, just to speed things up, I have typed the code here, so let's copy and paste it right there. So here, if the selected value is contract employee, then we are loading only contract employees. On the other hand, if it's not permanent or contract, then it's going to be all employees, in which case we are loading all employees. and calling the data bind method. So with these, let's save all the changes and let's go ahead and run the project and see if we get the output that we expect. Okay, so when I say load all employees, look at that, we get all the employees. When we say load permanent employees, we get only the permanent employees. Look at the annual salary column. And when we say load contract employees, we only get the contract employees. Look at the hourly pay and hours worked. Now let's say when I select load all employees, I want all the columns. For example, hourly pay, hours worked, and even annual salary. If that's the case, then we need to write some code within the code behind file, because look at this, when we select all the employees, now it's the list of abstract types it is returning. And if you look at the employee entity, it has got only these properties: ID, first name, last name, gender, and that's what is displayed by default. But if you want other properties of the derived types, that is hourly pay, hours worked from contract employee, and annual salary from permanent employee, then you need to cast the employee type to those respective types if they are of that type, and then retrieve those respective properties and then bind that to the grid view control. Now to speed things up, I have written a private method which can do that. So let me copy and paste this within the code behind file, and then we'll quickly go over the code. Now this is not entity frame related to entity framework, it's pure .NET code. I mean, all we are doing here is making this private method return a data table. Now data table is present in system.data namespace, so let's go ahead and bring that in. Okay, so what we are doing here is, to this method convert employees for display, we are passing list of employee objects. Okay, and then we are constructing the data table. So this data table is going to have all these columns: ID, first name, last name, gender, all the columns that are present basically within this employees table. Okay, so we are adding all those columns to that data table, and then whatever list that gets passed into this method, we are looping through each employee object within that list, and then we are creating a new row based on the data table that we have created right here. And then we are populating column values for ID, first name, last name, and gender. Okay, they are common for both permanent employee and contract employee, so we are doing it here. And then we are checking, okay, this employee object that we are talking about, is it permanent employee? If it's permanent employee, then typecast it to be of type permanent employee, retrieve the value for annual salary property, and store it in this column of the data row that we have created, and set the type of the employee to permanent. Okay, if it is not permanent employee, then we know it is going to be contract employee. In that case, typecast the employee type to contract employee, retrieve hourly pay and hours worked, store in the respective columns, set the type to contract, and then finally add that row to the data table. Okay, once we have looped through all the employees, all the rows are added to the data table, return the data table. So very simple private function here. And what we're going to do is use this private function in our switch statement. So when the selection changes, if it's default, we are going to get the list of employees. So this list, pass it to this private function. So that's the name of the function. So this expects a list of employees, and this is returning list of employees. And once you pass that list, this is going to create a data table based on that list, and then return that, which is going to be the data source for the grid view control. Now let's run this. There are some build errors. Let's look at that. Oh, that's because of this text. Let's get rid of that one there. Oops. Alright, let's go and run this now. Load all employees. Look at that. Now we get all the columns from the underlying database table. At this point, let's actually fire up SQL Profiler and see the queries that are generated behind the scenes. So let's run the trace. So first let's select contract employees, permanent employees, and load all employees. Now let's go stop the trace and look at the queries. Look at the query right here. So it's loading all the columns: ID, first name, last name, gender, hourly pay, hours worked, from this table. And look at the where condition, where discriminator equals contract employee, because that's the column we're using to check whether if an employee is a permanent employee or not. And this query is automatically generated by the entity framework. Okay, and when we selected permanent employees, look at that, where discriminator equals permanent employee. And when we selected this all button, then it has generated this query. Look at that, where discriminator in permanent employee, comma contract employee. Alright, so that is table per hierarchy inheritance. That's it for today. Thank you for listening. Have a great day.